comments, please go and use your vote. So we have been getting these like midnight desperate messages that some of you might need some more time with exercise 6. That's fine, of course, then it should be fair for everybody. So of course, like if you have a proper reason, it's fine to submit late. And also if you're still in the midway, do submit, you can get some of the points, or then if you submit like, let's say 2 weeks late, then we'll give you some minus point for the late submission, but still. But yeah, let's see what the vote is. I don't really care what the deadline is, just that then it's extra effort for those who are checking the exercises if we have to go one by one to look for the tasks. So that's why maybe would propose postponing until Friday, so you get to learn all the stuff that was there in exercise 6. So let's check that soon. Otherwise, thoughts about week 6 or the course as a whole? That's maybe a big question. So difficult, excellent, bit more challenging. So okay.
Yeah, it looks like this exercise from this week, we heard feedback from the course assistants that you guys were having a bit more difficulty with this one, and it's not a big surprise. Pretty much the last 3 or 4 years that we've been teaching the course, exercises 5 and 6 have been the ones where you make the kind of biggest jump and have proven to be the most difficult as a result. And of course we want them to be challenging, but we don't want them to be so difficult that you're just like deciding you don't want to study Python anymore, or giving up on your life because this exercise is so difficult. So in some sense, it's good to see that it's challenging, because that's the idea with these last couple, is that we really move more in the direction of dealing with real data and with the steps that you go through to process real data sets. But we also recognize that we kind of accelerate, especially compared to the earlier parts of the course in these last few weeks. And
the idea is, of course, that you start to look at the documentation, apply new methods that we haven't taught at the lesson, and of course, like the exercises are a place for you to learn. So learning continues there after the lessons. So it's part of the package.
Yeah. So are there any questions or anything that you guys have about this exercise number 6 or lesson number 6 material? We can perhaps come back to this deadline at the break once we take a look at the poll output and see, maybe we could take a look at it now, but let's see here. If we got the slash screen at the end of that, it should show.
Yeah, that's true.
Let's see what the votes are looking like so far. So we've got 11 votes for yes, 2 votes for no. It sounds like we're going to extend the deadline then to 4 o'clock on Friday. So you have a bit of extra time. And most probably, already our deadline for exercise number 7 is also a little bit extended from the typical schedule, because this is our last week that we're here in the classroom, and so we're giving a little bit of extra time for a couple reasons. We'll come back to that at the end of class today.
Are we online already?
We are,
okay.
Yeah.
Maybe we could say a few words about period 2 at this point. So some of you are finishing now after period 1 Geo-Python course. Some of you are continuing with automating GIS processes course, and then some of you might continue off to the introduction to quantitative geology course. So maybe we need to switch from here as well.
Yeah, we can put this
laptop 1.
Laptop 1, yeah. Yes. So from the course page, you can find links to information about both courses. I know at least for the Introduction to Quantitative Geology course, the current version of the webpage is from last year still. It has not yet been updated, but you can find links there. I don't know if you want to say anything specific about the AutoGIS.
Maybe a few words on the Automating GIS Processes course. So it's indeed a master's level course that's worth 10 credit points if you do the whole autumn. And I have sent a message to everybody who was registered for period 1. So for admin reasons, I would ask everybody to re-register for period 2. I'll still remind you about it when we start So now I have 37 students who have re-registered. So maybe some of you still should go once to WebAudi and register for period 2. So we'll dive into spatial data analysis. We'll use GeoPandas, so sounds familiar to pandas. So we'll build upon these methods then to start managing and analyzing spatial data and plotting maps and doing some accessibility analysis using Python and such. So it's a nice course.
Yeah.
Looking forward to that.
And for the quantitative geology course, of course, you can find the course information online as well, so you can read through that. This would be the material. It's more or less going to be covered in the version of the course that will run this year. There will be some small updates, but you can get a pretty good sense of what the course is about here. This is a separate course from the Geo-Python course, so you would register separately for the Introduction to Quantitative Geology, and it is intended for bachelor students, but I don't really restrict things too much. So oftentimes there's master's students, particularly master's students that are exchange students or other kind of visiting status people. I generally let them just sign up in the course and take part. I think you can find the information in WebAudi about when the course meets. I think it's on Mondays from 9 to 12.
Yeah, I posted WebAudi links on Slack in the general page, so you can go check it out from there. I think lessons are Mondays for both courses.
I think so.
Ours is at 4 p.m. and then, rather 4 than 8 a.m.
Yeah, so we've got 9 o'clock for the Introduction to Quantitative Geology, I believe. And anyway, the basic idea with the course is that we continue on with some of the Python skills that you've learned in the Geo-Python course to learn how to put equations into Python, to create plots, and to sort of explore how different equations that are applied to geological problems can be manipulated, and what you can learn from playing around with the variables in certain equations. So that's
Maybe I said master's level course for automating GIS processes. Of course, there's bachelor's level students. You're very welcome. Maybe the only pre-knowledge is that you should be somewhat familiar with desktop GIS software. So that's maybe.
Yeah. So other than that, I guess we can continue maybe.
Yeah. Let's go to lesson 7.
Yeah, I think everything should be up to date now on the course page, so we can go here to the lesson overview, and I guess I'll let Walko walk you through.
Yeah, I'll say a few words, and then I guess Dave will do most of the Python teaching today. So, plotting, question. Okay, who are on CSC notebooks and can't see the lesson notebooks? Okay, and who can see the lesson notebooks? Okay, so same situation as last week. Maybe we'll do so.
Maybe we can. Have you tried destroying the instance and relaunching?
Yeah, we might need to do this git add, git pull thing. What you could try to do just before we go around, you could navigate to the notebooks lesson 7 folder, run git status, check how it looks like, and run git pull. That might fix it, or then you might have to add and commit. No, it's the notebooks file. Yeah.
We can maybe come around and help.
Yeah.
If you're not seeing the lesson 7 notebooks. First thing I would say is to destroy the instance and relaunch.
Yeah.
Because we did update the notebooks not so long ago, so it's possible that the updates didn't get pushed through on all the instances, but otherwise perhaps Lotta and myself can come around and help.
So let's do so. I'll start introducing the topic. There's like 5 minutes of no hands-on stuff, and then we can switch, and I can still come around if somebody didn't access the notebooks. Anyway, but lesson 7 on the web pages. So plotting is the topic for today. And then let's see, we can maybe start from here. So as you see from this figure, there's many different approaches to do plots programmatically, but what we will be focusing on is to use pandas, which then takes use of the Matplotlib library. So we'll be focusing on that, but then as you can see, maybe in the future, maybe you have already come across some other tools for mapping either in Python or then in other programming languages. So for example, then JavaScript is another big kind of chunk of tools that you might come across when looking for methods on how to plot things. So Matplotlib, that's the big package for plotting in Python, and it's basically, as I understood, based on the kind of MATLAB approach of plotting things. Then there's some other libraries that's good to at least be aware of. We will use Bokeh a bit today, so for making interactive plots. Then Seaborn, let's maybe see if I can open this one, is a library that kind of builds on top of Matplotlib, but is kind of very useful for making kind of fancy visualization. So we use that quite a lot in our lab. So these kind of niceified, nice preset color schemes you can then do with Seaborn. And already in this week's lesson, you can use some of the Seaborn styling when doing the plotting. Plotly, we've used that in the past years, but won't cover it this year, but you might want to check that out as well. Those of you who have used R are probably aware of ggplot. So those functionalities can be also used through Python. I haven't used that myself. And so on. But indeed, Matplotlib is the main library that we'll be using. And you will probably need to, when then doing actual coding, modifying the plots, you might have to extensively use the Matplotlib documentation in order to know how to manage and control the way in which your plot looks like, but mainly we'll do things through Python that then under the hood uses Matplotlib. So on your own time, you can browse through, get some inspiration if you're thinking about how to visualize your master's thesis data. So there's a lot of existing examples online. Okay, so then we could spend a moment to define what is actually a plot. What are we talking about? So one example is a classical XY plot. You have something on the x-axis. In this case, there are months. Something on the y-axis. In this case, it's proportion of visitors to a national park per month, or the proportion of social media users per national park per month. So this example is from our project Social Media Data for Conservation Science. I could link then the final paper which this plot is related to. So eventually we then created plots for all Finnish national parks, all South African national parks using Python. Okay, but in general, in a plot, you have some data plotted. So this is a line graph. You might have a scatter plot or box plot or bar graph, different types of plots. Then there are these on the x and y axis. You have the axis labels, x label, y axis label, or y label. Then you have the ticks in there to show, so you can control all of these different elements. Do you want to show the months? Do you want to show the exact dates? Do you want to show percentages or decimal numbers? Then there's a legend. So the blue line is the social media data, red line is official statistics. What else? Then we have a title. Did I miss something? there's some grid lines and stuff. So all these different elements you can then control when plotting things in Python. You'll get some kind of a default plot, and then we can start modifying those. Yeah, and the basic vocabulary, I think it's probably quite familiar to you, but then when kind of Googling for help, how do I control the y-axis range? So then you'll need to use these kinds of terminology when Googling, like pandas plot y-axis, how to change it, in short. Okay, that's most of it. Maybe I'll just give the floor to Dave, who has prepared most of this stuff, and I can come around if some of you are still having troubles with accessing the notebooks. And maybe still to mention while Dave is setting up the monitor, so when we are plotting maps in period 2, we are doing exactly the same thing. We're plotting data in a plot, and then of course if we're plotting spatial layers, we'll plot them on top of each other in the same figure object. So it's not much more difficult than plotting XY data. Okay.
Yeah. Okay, so how many are able to see the Lesson 7 notebooks now? Is there anyone who's still not able to? Okay, so we've got a few people maybe in the middle here and one on the end. I guess we can come around. Please try to make it known to Lotta or Volko if you see them wandering around with nothing to do, that you need some help. So yeah, so we're moving on to data visualization. We had a little teaser about plotting some data back when we first introduced pandas, because it is really not that difficult to go from loading data into a data frame to getting a plot of the data with pandas. That's one of the nice things about the pandas library in general. But our first step is going to be more or less like what we did last week. I'm going to jump here over to my Jupyter lab. So this is now on the CSC Notebooks platform with the first part of the lesson today. It's titled Matplotlib, because we're going to be doing plotting with pandas, but also Matplotlib and a bit of bokeh on top of that. So like last week, we're actually going to work with the same data we had from last week, but we're only going to grab one data file just for the sake of making things a little bit easier. Of course, everything we're doing, you could easily repeat with whatever, 15 data files, generate plots for all of the different stations, but we're just going to grab the station for the Helsinki-Vantaa airport. And like last week, we have to do that using the terminal. And I'll go through that now because I don't yet myself have the data, and we can see whether this process works like it's supposed to. First, I'm just going to go to File, New, and then Terminal to get myself a new terminal. And I'm, just, like last time, just going to grab the tab and drag it down to the lower half of the screen so I can see the lesson and I can see the terminal as well. If I look at where I'm at here with the ls command, maybe I can make this bigger. How did I do that last time? I feel like I zoomed in somehow. Increase text editor font size, maybe that's the one. Terminal font size, there we go. And I'll make terminal font size a little bit bigger. Perhaps that's a bit easier to see. So yeah, I'm just in the base directory, the work directory where my instance started up. And I'm going to go to CD to notebooks. And because I'm just used to it, I hit tab to autocomplete. So like once I type in NO, I could just hit tab, and since there's no other thing starting with NO, then the operating system knows to put in notebooks for where I'm going. And I'll do no/no and hit tab, and then to L7 for lesson 7. Oops. In here, there's a few IPython notebooks or Jupyter notebooks and some other stuff, but we don't have a data directory. We don't have our data file yet, so that's what we're going to do next, is grab that. And you can do that basically just by copying and pasting this command, this wget command, just like what we did last week. I'm just going to copy paste the wget command here and run this, which will then pull down the data file that we're using. It should come pretty quick. It's 11 megabytes, so it's a bit smaller than what we had last week. And if I type ls now, I see I have my Finland weather data l7.tar.gz file. Anybody having trouble with that part so far? Okay. So once you have the data file, you can use this tar command. It's tar zxvf. As I mentioned last week, it's we don't need to know exactly what those things do, but you can do tar zxvf, and then you can type capital FIN and hit tab, and it should fill in the rest of the file name there for the Finland weather data. When you hit enter here, it's going to extract our data. You'll get some warning messages about stuff. Don't worry about it. But if you type ls, you should now see that you have a data directory where you did not have one previously. And if that is the case, then you're basically ready to go with the lesson for today. We'll use the same lesson in both the first and second part of what we'll do with our data plotting today. Any trouble so far? Other than those who are not able to get the lesson 7 notebooks. Okay, fear not if you're not able to access the lesson 7 notebooks at the moment. You can just follow along here. But we've got our data, and that stuff's all set. I'm going to drag this tab back up here to the top, to the tab bar, so then I can just go back to having this full view of our notebook. In the data directory, I didn't show it, but there's only one data file. This is 029740.txt. That's the weather station data for the Helsinki-Vantaa station, and then otherwise there's metadata that describes what we're looking at. We saw this stuff last week, so we don't really need to go through it in any detail. Now, to get started, I've left a few things in here for you. We've already done the import pandas as PD thing before, so you can just shift enter and run that cell. But the next cell has a couple things different than what we saw last week. So last week we had already used the read CSV function. We had used that even the week before. We'd use this delim whitespace equals true thing that would just say if there's spaces between the columns, just treat that as a column separator. We dealt with that. We did the NA values thing where there's different numbers of stars that can get converted to not a number automatically. And we also had done this use calls thing where we selected only certain columns out of our data file. So rather than reading all 33 columns that the data file has, we're going to pick out these 4 that we're actually interested in so that we don't need to deal with the rest of that junk. The difference here is in the last line. There's 2 things here that are new. One is parse dates. What this is going to do is it's going to take whatever column or columns that you list here inside square brackets. So this is expecting to receive a Python list as what you should have for parse dates. It's going to take this, and Pandas will do its best to convert whatever the data is in that column to a DateTime object. So it will read through there, and if it finds something that's in a format that looks like a date that Pandas is familiar with, it will then automatically convert that to DateTime object, which means you can do nice things like we saw last week, like selecting the months out of there easily, selecting the year, selecting the day. And when it comes to plotting, we can avoid one nasty thing, which is that sometimes if you don't convert to a date along the x-axis, your plot can have sort of unusual spacing between the points along the x-axis. Can I zoom in still a bit? Yeah. Is that better or even more? Yeah, that's okay. So parse dates is going to allow us to convert the data values from this year mode column, which has our date information. to a DateTime object, which will be nice. And the other thing that we're going to do differently here that we have not done previously is that we're specifying an index column. So instead of having our index values start at 0 and just for each row go up by 1, we're now going to say, let's index our data by the dates themselves. If you have date information in your the data file you're dealing with, this is often a really nice way to be able to select ranges of values without needing to know what the index values are themselves, but just the dates that you're interested in. So this index call will allow us to define a certain column that will be used as the index. So we'll see what happens when we load this in. If you press Shift Enter, you're going to have to wait a moment because the data file is pretty big. I think it's about 930,000 lines, so it takes a moment for it to be read in. Of course, it's also 33 columns. We're only taking certain columns, and we're converting our dates to DateTime. So you remember that stuff took a little while last week. That's still the case when we read the data right now. So you can see here a little description in case you've tuned out about what the parse dates and index call can be used for. I'm going to keep an eye on this little star symbol here, and once the star turns into a number, then our data file will have been read and we can move on to taking a look at what we have. Okay, at least for me, that's now done. And yeah, now we can continue on. So we can first just take a look here. We've loaded our data variable, our data into a variable called data, a data frame in pandas. So we can do things like data.head. And if you data.head and hit enter, you'll see we've got data starting from 1952 on the 1st of January. Notice that our index that would normally be a number starting at 0 on the left side is actually a date value. And you can see the nicely formatted year, month, day, and then time information here. I think with pandas date times, you could even go down to like milliseconds or even smaller if you had really high temporal resolution. Unfortunately for the geoscientists, I don't think this does millions of years, but at least we can deal with human timescales in here without too much trouble. And we can see we have a temp column, a max and min columns that contain some numbers, and these temperatures, as you might imagine, the 1st of January, it's not 36 degrees in Celsius, but rather these are temperatures in Fahrenheit. So right around freezing in Fahrenheit temperature. Okay, so with that, we're already in a position where we can make our first attempt at plotting something. I'm just going to scroll ahead here in the lesson so I follow along. We do need to do one little magic command here first that will just help us with telling the Jupyter Notebook to put our plots directly in the notebook. So there are these things inside Jupyter Notebooks called magic commands that can do various kind of configuration things for you or special non-exclusively Python things. One of them is that if we type %matplotlib inline, we can configure the plotting environment so that when the plots are displayed, they're displayed within the Jupyter Notebook. Strictly speaking, this is not required, but the first time you run a plot command, it would not show the plot if you don't do this. If you rerun the command, it then shows it, but let's just do it because it's a good practice. So if you do this %matplotlib inline, you won't see any output, but now we're more or less ready to go. And we can now say AX equals data.plot, and that's it. Making our first plot in pandas is essentially just the name of the data frame, .plot, and then a couple parentheses. And we're assigning it in this case to a variable called AX. I'll explain that in just a second. But like reading the data file, if you hit Shift Enter on this cell, you'll have to wait a moment. As you have already surmised, it takes a second for some million data points to be plotted, or line connecting millions of data points to be plotted here. But yeah, we have a plot. And we can see a couple things here that we sort of expect to see. On the vertical axis, we have temperature. It's not labeled, but we can tell that these are temperatures because they're right around temperatures that we might expect for typical values here in Northern Europe. And along the horizontal axis, we can see our time. It's labeled here with the name of the index column, but you can see the year then for the tick marks there. So we've got our data, remember, starting at 1952 and going up to 2019. We don't see that as a tick, but you can guess that that's what we have. You can also see that we have different colored lines. So our temperature data is in blue, the max temps are in orange, and min is in green. You don't see too many of those because there's a lot of missing data for the max and min. So there's far less to be shown than for temperatures. And we've got a data void in here in the maybe mid-1960s to early to mid-1970s where there's missing data. When you do a line plot like this in Pandas, the default is to plot a line. It just connects the points between the missing values. So that's why we have that horizontal line there. It's not that we had 10 years of a temperature constantly at 40 degrees. So yeah, what happened? Well, we used the plot method to make the plot. We saw this earlier in lesson 5, I believe. And then we assigned the output for this plot object to a variable called AX. The reason for doing that is not necessarily something that directly affects us here, but if we want to go and then make modifications to aspects of the plot, the way we can do that is by assigning the value to refer to this particular plot to some variable called AX. And if we check out what we have for the type of the variable AX, you can just type AX. We see here that we have, a Matplotlib object. So it's something that tells us right away Pandas is using Matplotlib behind the scenes. We don't see it as a Matplotlib plot. We don't exactly follow the format of making a Matplotlib plot. But what we have is more or less a Matplotlib axes object that is something that means we can also use some of the Matplotlib functions and Matplotlib features to interact with our data plot, as we'll do later. Now, we may, in this case, benefit from not working with all of our data in a single plot because, as you can see from the line plot here alone, there is a lot of data, and it's not really very easy to see at this long time scale and the resolution we have. I think there's, I don't know how many measurements per day. It might be something like 30 values per day for some of the more recent observations here. So if you've got 50 years of data, that's quite a lot of points that we may or may not want to see. So let's select some time slice out of here. And what we'll do is we'll just take one day. We'll take October 1st of this year, and we'll take the October 1st, only the temperature values. So we're going to make a variable here called oct1 temps. And this will be our data in the locations. Actually, let's do it like this. Let's do data temp. So we only want to take values out of the column from our data called temp. In locations, so this is the .loc that you might remember from last week. It allows us to choose a selection of values where our index, which we'll type here as data.index. Now that we're indexing with time, we're going to use data.index instead of referring to the column name like we did previously. And we'll say that the data.index value is greater than some character string. And the character string we're going to give here is that it should be greater than 2019 10/01, so first day of October, and then 0000, so midnight on the 1st of October. Our data set only goes until the 1st of October, so this means we're only going to get the last day of data in this selection that we have here. And so now we're going to create a new, in this case it won't be a data frame, it's going to be a Pandas series because we're selecting only a single column out of our data frame. But we can now plot our data for the 1st of October just by doing oct1 temps dot plot, and actually let's go ahead and follow a good practice and just assign this to a variable called AX. We're not interacting with it at the moment, but let's just get used to doing that. So if we say AX equals oct1 temps dot plot, this will plot all of the data in the oct1 temps series. We have only one thing to plot there. So now we just get our single line, and you can see how the temperature varied on the 1st of October of this year at the Helsinki Vantaa airport. Again, temperatures here reported in Fahrenheit. And you can see in this case, because we only have a data series, we don't automatically get the legend to be displayed. We can display that if we want to, but I'm not going to worry about that at the moment. If you're curious about how to do that, you can find the pandas documentation, and it's quite straightforward to display the line legend. But here we only have our temperature, and as a result, we don't have a legend that appears. If there was more than one thing that was being plotted, we would have the legend automatically show up. The biggest thing here is that we're just selecting our time range, and this is a kind of reminder about how to choose a given time range. Here, when we're using a DateTime index, we're using this data.index as our way to refer to the date range that we want. Is that somewhat clear how that works? It's more or less the same as the way you would do it if you had a date column separately, but now we refer to data.index to choose the range of dates that we want.
Just a side note, I wasn't actually listening now. You can also do just 2019, and I guess you'll get the same. Now, of course, if you want to, like if you would want to do 1 year, so
yeah.
It depends on the date range you want to.
Yeah, that's right. So what Volko was saying is that if we wanted to choose a different date range, we don't necessarily need to specify the hour and minutes parts. So if we said like it should be greater than, well, actually in this case, if we choose greater than October, we're going to get a complaint that the month here in this case is outside of our range of months that we have. If it has to be greater than October, that would be November. We don't have data for November. But if we said greater than or equal to October, we get the same complaint. Why are we getting the same complaint? I think it's assuming a different data format because I haven't specified a day here. It's assuming this is, yeah. Okay, anyway, I would have to add the date in here, the day rather in here in order for this to work this way. There are other ways to do this a little bit more nicely, but the point here is that we can easily choose our range of dates with the same kind of .loc approach that we used previously, but with our data index now. And yeah, we get a plot that looks like this. Now we can see a little bit more of what's happening. Now our next step is to make it look a little bit, I don't know, I sort of hesitate to call this nicer, but let's make it look different. So first, we can start with what we had before, our AX equals, and we'll do the same oct1 underscore temps dot plot. But now we're going to add some stuff in here about how to format the plot, because we can do that, and there's some handy things to test out here. The first one is style. And inside style, you typically give some character string that then specifies in the Matplotlib format how you want to style your plot. So this time we're going to say RO and then 2 hyphens, 2 dashes. I'll explain in just a second what that actually does. But while we're in here adding stuff, we can also add a title. And we could say our title equals Helsinki Vantaa temperatures, or something like that, whatever you want to put as the title, you know, my first plot, or whatever you want to call it. So we can add that, but let's not press Shift-Enter just yet, because it'd also be good to label the axes of our plot. One thing I find personally a little bit funny in Pandas is that we can't do this, as far as I understand, directly within the .plot method or .plot function, but instead we have to now use a little bit of Matplotlib style things to add axis labels. So now we can do this ax.set underscore x label. And with that, you can then specify some text you want to put on the x-axis, perhaps date. And then ax.set underscore y label. And in this case, we can put something like temperature. And if you want to be fancy, you could put temperature, degrees Fahrenheit, as the y label that will go on the y-axis. Again, for these labels, the text itself doesn't necessarily matter so much. You can do fancier things than this if you want, but we'll just show you some basic things for the moment. If you run this, you'll now see you get a bit different looking plot. And we can refer back to what we've done to see how our plot has changed. The data that's being plotted, the range, if you look at the plot we had before, our data is basically the same thing we plotted previously. But our style has changed the color of both the line and the markers that are on here to be red. So the first thing we're specifying here in the style is this letter R for red. We can specify all these things separately, but this is a shorthand way to do it. It's just to put an R here. The O is going to put a circle for all the data points. So that's why we can see data points here now where we just had a line previously. And although it's a bit difficult to see, when you put two dashes together like this, you get a dashed line connecting the points. So there's shorthand. Yeah, this is the kind of shorthand way to format the plotting line format, and there's information on the Matplotlib website about how to tinker with this stuff if you want to change the colors or change the style or whatever. Title, I guess, is pretty much self-explanatory, and then the axis labels are just done using this format, and we can see them, of course, then on the plot as we would expect. So we can format the plots without too much difficulty, and that's nice. It's also explained a little bit more here on the course page if you're still confused about something. But in addition, if you want to find documentation directly within the notebook or within Python about using these plotting options, you can take one of your data frames, like in our case, oct1 temps. This is a data series in this case. But if you do help oct1 temps.plot and run this, you'll now get a rather lengthy description of how to do plotting for data series and how to interact with your plots. All of the different variables that you can, or parameters you can supply to change things that's about what is being plotted and all of that stuff. So I would encourage you to have a quick look through here, at least at the first bit, just to see what the options are. There's a lot of text here. I think it's quite excessive in many ways because this covers not only line plots like what we're seeing, but also bar plots and basically all of the other types of plots that you can generate with pandas. So there's a lot of stuff to scroll past here once you pull up that documentation. Yeah, let's scroll past the same stuff here on the other screen I have with the lesson materials. So the default plotting size, at least for me, is a little small on the screen for these plots. So one thing you might want to do is to make them bigger. And you can just run the cell that is here that has this, first off, importing Matplotlib, because although Pandas uses things from Matplotlib, it does not import Matplotlib in the normal way to do so. It has stuff that's available directly within Pandas. So to change the figure size, we have to import Matplotlib and then set this parameter that says the default figure size will now be 12 inches wide and 6 inches tall. That's inches for whatever reason. That's the unit that's used for the size. If you run that, you won't see anything, but if you go back up, if you're feeling bold and you want to scroll past all this junk from the output we had previously. If you rerun one of the cells where you had a plot before, you'll now get a much bigger plot. And of course, you can tweak that to the size of your screen on your computer or whatever. Or at the end of this part of the lesson, we'll get to saving the plots, and you can, of course, set the size there before you save them as well, so you get plots of a suitable size for your master's thesis or bachelor's thesis or website or Twitter or whatever you want to do when you share your plots. So you can change the size pretty easily this way. This is setting the default plot size for all plots. You can also do this another way that we'll see in the second part of the lesson today. If you want to set certain, like kind of figure by figure, how big the plots are, you can do that as well. So a couple other things you might want to do with your plots. One of them is to add some text somewhere on the plot. We can do that using the ax.text. So again, ax would be the name of whatever your plot object is called. It's the axis for the plots. So I'm assuming it's ax because we've been using that so far in the lesson. And then you give a position in terms of the x and y coordinates on the plot itself of where you want the text to be displayed. And then in quotation marks, the text you want to have appear. We'll see how to do this in just a second in an example. We can also change the ranges of the axes. Of course, you can do this as you would expect, and that's done by supplying the x lim or y lim. These are the limits of the x and y axis. You supply those parameters, and then in a Python list, you list the starting value on the x-axis, so whatever the leftmost value should be, and then the x max value, the value on the right side of the x-axis. And similarly for y min and y max, you can provide those values as numbers. I've put them in here just as text, but of course you should replace that with the number or date or whatever it is to use this yourself. Now, the only other challenge we have is we have chosen to use this DateTime index in reading in our data file. There's good reasons for doing that, but it does make the plotting a tiny bit more tricky because now we don't have something that's a regular number on the axis, but we have a DateTime object. So in order to specify things like what the minimum and maximum value should be along the x-axis, we have to specify those as DateTime limits. We can do that pretty easily by using the pandas pd to DateTime function. So if you just type pd.to_DateTime, you'll see how pandas handles a string and tries to convert it from some format to a date. So if we put in, for instance, 1 o'clock on 1 o'clock in the afternoon on the 1st of October, we can do that as 2019, 10:01, and then 1300 for the hour and minute, or you can copy paste this from above. But if you just run the cell, what you see is you get back this timestamp that now is formatted in something that looks a bit more familiar in terms of a date format as 2019-10-01, 13:00:00. This is a nice thing to allow you to play around a little bit with how pandas is going to try to guess to convert some character string into a date. If you add dashes in here, for instance like this, it still works. If you put some weird character like a capital D in the middle of this, you're going to get an error message because now you've given pandas something where it's like, okay, I thought I knew what was going on, but now I don't know what to do with this D. This doesn't seem like it fits with things that I'm familiar with. And so it's going to have a problem there. You can also see here, for instance, that you can leave off the hour. So if you leave off the 1300 at the end, it's just going to convert the time to midnight on that day. You can also leave off the day, and it will then assume that it's the first day of that month. Or you can leave off everything but the year, and it's going to convert that to just being the first day of January in 2019. The problem I had before was that when I did this 2019 10 Pandas doesn't know whether I'm trying to specify these first 2 digits as the year, and then 2 for the month, and then 2 for the day, or some other kind of format. This is ambiguous. So as a result, I don't know exactly what the error message is, but it's complaining about something about not understanding what the month is here. If I was to put in, as we saw, a dash here, now it's clear that the first 4 numbers are a year and that the last 2 are a month. Now Pandas says, okay, I can do that. I can handle converting this. So anyway, when we deal with this stuff, we want to set X limits with the DateTime formatted index or values along the x-axis. We have to convert them to DateTime objects like this, and this is just a simple example of how to do that, and good opportunity to show you can play around with seeing what you can give Pandas. It's pretty good about guessing what the date format is for a lot of different common formats. So I think similarly, if we put in 2019.10.01, no problem. So I don't know what it's going to do if it goes with like the US format of putting the month first and then the day and then the year. That probably won't work without some additional information. But yeah. Okay. So now let's modify our plot a little bit. So previously up here we had some, well, it was way up. We had a plot from the 1st of October of all the temperatures, but let's look only at the temperatures in the early afternoon on October 1st. So we can do this by setting a start time, or a variable called start time. And that will be a DateTime object, so we'll do PD to DateTime. And if it's on the 1st of October at noon, that'll be our starting time. So that's going to be 2019, 10:01, and then 12:00 for the hour and minute of that day. So that'll be our start time. I'm just going to copy this and paste it down below so that we can have also an end time. And instead of starting, well, yeah, we start at 12, let's end at 1500, so 3 o'clock in the afternoon for our end time. And we'll add one other thing here called cold_time. This will be used to indicate the coldest time of the day, or at least during this early part of the afternoon. Again, I'm just going to copy the PD to DateTime stuff from above so I don't have to type all that in. And I can tell you it's about, well, it's at 12 o'clock. I know that just from having plotted this earlier, but you, of course, could figure out what the coldest time is yourself if you wanted to, and add the thing manually. I'm going to put the text label here to be at cold time, and I'm going to put it at the time 12:05, so it's just slightly offset from where the point is displayed on the plot. You'll see what that looks like in just a second. Okay, we should also add some X and Y limits in here, because we can see here that we should look only at temperatures between 40 to 46 degrees Fahrenheit. Let's start with the XLim, and this one's kind of easy because we're just going to say XLim equals brackets start time, or start underscore time, comma end underscore time. So that'll allow us to specify the time range along the x-axis pretty easily, and we can then say also ylim equals, and then square brackets. And here we'll just put 40.0, comma 46.0. So you could put in numbers, or you could put a variable value if you have a variable with numbers that are stored in there. But this will be our minimum temperature and maximum temperature on the y-axis of our plot. And then down here, finally at the bottom, we can add a command to plot some text on here. So we'll do ax.text. And again, for the ax.text, it expects the first thing to be the x-coordinate of where to plot the text. Well, this is going to be our cold time, because along the x-axis we want to be at the coldest time of day, which is just right around 12 o'clock. So we'll put cold underscore time here. And the temperature value, as it turns out here, is about 42 degrees at that time. So that'll be our value along the y-axis for where we'll display the text. And then finally, the text we're going to display is I'll just put a little arrow thing like this. So just a little less than symbol and then a dash and just cold time. Whatever. You can put any text you want there. So we've added a couple things here. We've added these kind of time limits for where we want to start and end our ranges of values on our plot. So now we're specifying those with the xlim and ylim values here. And then we're also going to display some text. The plot is otherwise set up to be basically the same as we had it before with this nice red dashed lines. Now that things are a bit bigger and we're zoomed in because our time range has changed, you can see the dashes a little bit more easily. But you can see, for instance, here on this date, the 1st of October, at 12 we start, at 1500 we end. You can see our text now is displayed here at 12:05, so it's going to be the left edge of where the text would be displayed is what's specified with the x, y coordinates. But it kind of looks like an arrow pointing at that dot, that first value at 12 o'clock. And then our range of values for the temperatures along the y-axis is from 40 to 46 degrees. Any questions about this formatting stuff at this stage? Yeah. Oops. No, I don't want to do bad things. Okay. So, yeah, this is just, some small tweaks, but already you can start to see that we're able to interact with our plotted data pretty easily. We don't necessarily even need to slice out the first day of October to plot this data from the afternoon of the first day of October. We could just put in the limits on the x-axis range to be from noon on October 1st to 3 o'clock in the afternoon. There are some reasons that we're not doing it that way, because in order to do the plot that way, we would still have to plot the entire data frame, and then it would change the axes after that. So all of the data would still be loaded into memory, and it would be then slower to plot. By just selecting out the first day of October, things are a bit easier this way. So we have our plot, and now we've got a task for you. And we'll take just a few minutes. I think we've got time to do this, so let's take maybe 5 minutes or something like that, or if you're done before that, we'll continue. But what I would like you to do is to take these examples that we've been working with so far and make a plot that looks something similar to what we have. So we'll take temperature data from 6 o'clock in the evening until midnight, so kind of latter quarter of the day on the 1st of October. So we should only plot those temperature data. And you should connect the points with a dotted black line. And you should not show the data points. And I will maybe put up the documentation just so that you can see the kind of formatting documentation to help with this. But then you should add a title that reads something like evening temperatures on October 1st. And a text label indicating the warmest temperature in that evening. You can go ahead and add a code cell beneath this task. I forgot to put one in when I updated the lesson. So that's your task, and why don't you take a few minutes and see how you can do with that. I will, in the meantime, pull up the documentation for the style of the lines so you can see how to do a dotted line and the rather unintuitive letter that you use for the color of a black line. so hopefully that's big enough that you can see the text there. This is just from the Matplotlib plot function. So has anyone managed to produce their plot yet? Maybe show of hands, who's... Okay, so a few. Would you like a few more minutes for those who are working, or would you like to see, yeah? Okay, let's wait just a couple more minutes and then we can, if you're totally stuck, we can see how to do this. right, so in the interest of time, I'm going to start slowly working through how to do this, so that you can see how to complete the requested task here. So we were asked here to put some temperature data from the 1st of October from 6 p.m. until midnight on a plot. And so the easiest way to do that is we already have our data from the 1st of October in our Oct1 temps pandas series, but we should put some limits on what's going to be plotted so that we can see only the times that we are interested in. So like we did before, we can have a start underscore time. And we could convert that to a date time using the PD2 underscore date time of the first time that we would like to see. Well, the first time we'd like to see here is 2019, 10/01, 1800. So this is 6 o'clock on the 1st of October of 2019. I'm just going to copy paste that like we did before to then be end time. And the end time in this case, I believe you can put either 2400 or 00 of the next day. Let's find out. I actually don't remember if I tested this, but let's just do it this way. We'll put 2400 in for the end time. So that'll give us our range of temperatures we want. And then we can do the Oct1 temps dot plot. We know the style here should be a black dotted line connecting the points. So the rather unintuitive letter for plotting something in black is K. B was already used for blue because that was the default color for plots in Matplotlib, following the default color used in MATLAB. So K is used then for black because it's the last letter of black and there's no other color really that's commonly used. It starts with the letter K, so let's use black. And then you should have this colon character to do the dotted line. So that's our style for the plot that we have here, K colon. Then we can add our title. Title equals, I'm just going to copy paste this, evening temperatures on October 1st, Helsinki Vantaa. Just grab that, copy and paste it in here. And we do need to now specify our x limit. So xlim equals, and then our square brackets, start time, comma, end time. So that gives us then the range along the x-axis for our plot that should correspond to what we've defined for our time limits earlier. The only other thing we have to add at this point is a text label. And so we might as well make something here called warm time, or whatever, warmest temperature in the evening. Let's call it warm time. And I will also then just copy paste this PD to date time thing. And I'm going to assume it's around 6 o'clock. I don't know yet, and I don't want to calculate it because that would take more time than it would to just display the plot and look. But I'm going to assume it's around 1800, so I'll make it 1805, just to have a little bit of offset between the text label and the line where the value is being plotted. And then we can do an AX, whoops. We should first do AX equals Oct1 temps, so that we can then do AX.text at warm time, comma, some temperature value. I don't actually know what this is going to be. It was in the 40s earlier in the day, so I'm going to guess it's probably around 38.0. We can move the label later. And then the text with the same format we used before, whatever. Warm time. So a bit of stuff to type in here. You could have basically just copied and pasted it from earlier and just edited what was already done. That's also an efficient way to do things. But now we've defined our start and end times, the warm time, and made our plot and added the text. I think we've done all of the things that were asked up here for this task. So if I do Shift Enter, I get a type error. I was not expecting that. So hour must be 0 to 23. Okay, so I cannot put 2400 here for the hour. So I'll put 00 here, and the end time, instead of being the 1st of October, as the 2nd of October at midnight. It's effectively the same time. So that was a nice little lesson learned there. Now, when I run this, I see that here is my time slice from 6 o'clock until midnight, but it doesn't actually look like I found the right warm time. It actually looks like it's gotten warmer later in the evening. So we can move our text label and even slightly change the format so that it's closer to about 10:45 or something like that at night, just so we get the right point there. I'm actually going to do it this way, that I'll put the text label so the arrow is on the other side, which means I'll then have to position it a little bit differently. But I can see the temperature here is around 42, maybe 42.5 degrees. So I'll also bump up my value for the y-axis to 42.5. And now I'll change my warm time. Instead of being 6 o'clock in the evening, which I thought would have been the warmest time, I will make it, instead of 18:05, something like 22:45. Because the text is going to be positioned from the left side, I'd like the text to be somewhere over here, pointing over to the right. We'll see if I put it in the right spot. So minor change there. Rerun this. Nope, it's not in the right spot at all. So we're going to shift it more over to the left. Maybe we make it an hour earlier and see if it looks better. So 21:45. Let's see how that looks. That looks better, but not good enough. So let's make it 22:10. Too close. All right, 22:05. This is the kind of thing where you can waste a lot of time with tinkering with your plots. But anyway, the point here is that we can do this task without too much difficulty using what we've already seen. We can add some text and things like this. Maybe this isn't the best way to show what we're doing, but it works. And so that's good. All right, now we're going to take a break here in just a moment. I will maybe take 5 or 10 more minutes just to finish this first part of the lesson, because it's good to finish this up and then move to the next thing after the break. But you can do bar plots in Pandas as well. I'm not going to have you type anything in here because the formatting is almost the same as making a plot with the format we've already seen. The difference is that bar plots are treated as kind of categorical data, so you can't define your x-axis range quite the same way that you can for a line plot. So in this case, I'm going to start by just choosing the afternoon of October 1st by manually taking all temperatures that are fitting this time range of the afternoon of October 1st. So this is just taking a time slice here from the Oct1 temps index value of times that are less than or equal to 1500. So this is the early afternoon. And then I'm basically following the same format that we had seen before. You can look through this stuff on the course page, so don't worry about typing any of these things in at the moment. The biggest difference here is that now we specify kind equals bar as a parameter in the plot to tell it that we want to do a bar plot. There's another way to do this in Pandas as well, but we'll just do it this way because I think this is the kind of most consistent format. If I run this cell, I get a little bit different results than I was expecting. I think actually what I was looking for was to have this be greater than or equal to, not less than or equal to. And Yeah, I must have made a change to this plot at some point and not updated things. We're supposed to be identifying the coldest temperature at in this afternoon time. Instead, I think we've got the warmest temperature, and I think maybe we'll not worry about this too much for the moment. We can fix this on the course page if need be. Yeah, because this plot doesn't look very good. Okay, let's skip past this one because we can do the same kind of thing here, where we just plot all the bars from the afternoon of October 1st. I guess this is going to not look so good though, so I do need to define some temperature range here that makes some sense. So let's say it's greater than or equal to 12 o'clock. And we'll update this on the course page so that you don't need to worry about this part. We'll just take greater than or equal to 12 o'clock and less than or equal to 3 o'clock in the afternoon, because I think that's what was there previously, and now everything looks okay that our coldest temperature is identified as expected. I don't know why, but the temperature or the sort of date range was not what it should have been there. Okay, so we can get our plot like this of bars basically showing us the same data we had for the afternoon of October 1st. Another thing we can do once we've created the plots is save them. And to save them, we use a Matplotlib function called plt.savefig. The only thing you need to give it when you use plt.savefig is a file name. And based on the file name, Matplotlib will then guess which format it should save the file as. So you could make, oct1.png. And if you run this cell here, it will produce the plot, and then it will save it as oct1.png. And it will recognize from that .png that you're looking for a PNG file. If you go over here and look, then you might need to refresh your view of the files that you have available. But if you take a look, you should then see that you have this oct1.png file available, and you can double click and, for instance, take a look at what that looks like. So yeah, that's a nice thing to be able to do. You can also save it as like a high resolution PDF file. If we just copy and paste the same thing that we had before, just this plt.savefig, change the file extension to be PDF, and then add in this DPI, so this is dots per inch, the resolution of the figure. We add DPI equals 600, and we'll then get a 600 DPI PDF file saved instead. And again, you can go take a look at that if you like. You'll see a nice high resolution image that's been saved. So the thing I want to do just before we take our break is one example of interactive plotting with this bokeh library that can be linked to pandas pretty easily using this pandas bokeh plotting backend. So to use this pandas bokeh thing, you basically just have to run the first cell here. It imports pandas bokeh. That should work on the CSC notebooks, and then sets the plots to be displayed in notebook format rather than in a separate window, which is the default, and then sets the plotting backend for pandas to use pandas bokeh, which means now that when you generate a pandas plot, it will try to plot it with bokeh instead. Bokeh is nice, as you'll see, for doing these kind of interactive plots. This cell you should be able to run, and you should see nothing other than this bokeh.js 1.3.4 successfully loaded output. It does look like I have not included the plot command here, so we're going to have to type this one in, and then you'll have earned your break at that stage. So here we have defined now a different date range. This is September 29th to October 1st, so we're making a different data frame from September 29th to October 1st, and that's then the data locations that have a date greater than the 29th of September. So that'll give us now 3 days of data. And then we've got a start time and an end time that correspond to those days as we have here. To do the plotting with this pandas bokeh thing, we basically follow very similar format to what we had before. So AX equals now our new data frame, September 29 to October 1st. We did this for a reason, because we're going to interact with the data. It's nice to have a few more days. We can then specify a title, and we could just call this whatever, same thing we did before, Helsinki, Vantaa, temperatures. We can also include an X label in here. So this is the difference from plotting in pandas itself. When you use the pandas bokeh, you can use the X label directly in here. So we know our X label is going to be the date, like we had before. Y label can also be specified in here, and the Y label is going to be temperature. Not going to bother putting in the degrees Fahrenheit in this case. And we can also specify limits like xlim, just the same way that we did before. So we'll have xlim go from start time to end time. And ylim, in this case, will go from, I guess it's 35 to 60 degrees. So more or less the same format that we had before, with the exception that now our X label is specified inside here. Our Y label is specified inside here. And importantly, this is a pandas data frame and not a pandas series. The bokeh plotting will not work with a pandas series. It needs a pandas data frame as the input. If you run this, data frame object is not callable. What have I done wrong here? I guess I need to add a dot plot in here. Perhaps that's a good idea, because yeah, minor oversight. Now if I run the cell, and hopefully you see the same thing, you get a plot that looks similar to what we had before, but we can play around with it. You can move your mouse cursor along here, and as you go along the axis, it shows you what the temperature values are at each point along the x-axis. That's kind of cool. You can also go and click on values in the legend, and that will make them disappear or make them visible. In this case, we don't see any maximum or minimum temperatures, so turning them on or off won't do anything, but of course with temp, we can hide that. And you can also use the scroll wheel or your trackpad to zoom in. You can click and drag the plot around. And if you want to go back to the original view, there's this little reset thing you can click. There are other things that you can do to interact with the plots. One thing I kind of like is that you can go to the axes themselves. And if you scroll with the mouse positioned over the axis, it will then scroll only in the X direction or only in the Y direction. So if you want to zoom in only in time, but you don't want to zoom into the values on the temperature axis, you can do that just by scrolling here, and you get nicely formatted dates that gradually change their display format and positioning of the ticks and things like that as you zoom in and out. So this is kind of cool. The other thing that's cool about this is if you go to the course page to our lesson for today and scroll way down to the bottom to where we have our example plots, these plots actually work just as nicely as they do in our notebook on the course page. So you can embed these in web pages, and I think for those who do the automating GIS processes course, maybe you'll get some experience with seeing how you can do this also with like data that is map data that's plotted so that you can have interactive maps on a web page and things like that. But it's nice that we didn't really have to do anything besides just call this extra library, and we can get these interactive plots in this format. And yeah, maybe things don't look super exciting with this example we have here, but of course you can make nicer examples yourself. If you want, we just copy paste the stuff we had here. So just copy this down to the bottom cell here. we can add one other parameter to our plot command. And that other parameter is called plot underscore data underscore points equals true. This is the way that we say we want to have a line with the data points displayed as well. The reason for doing that in this case, if we run this cell with the plot data points equals true thing, is that now we can see, oh, we do actually have some max and min temperature values, but they're so sporadic, there's not kind of continuous data there that there's no line drawn to connect them. There's just a few points here and there. I have no idea why these are sort of spaced out the way they are. But now you can see, for instance, why you would want to have things like the option to turn on or off various things on the axes. Like maybe you don't really care about temp, you only care about the max and min temperatures that are calculated at these different times. So this is a fun way to be able to interact with our data a little bit differently. Now, I have gone well beyond the reasonable time to push you without a break. So why don't we come back in, I think we need probably 15 minutes. This has been kind of high intensity. The second part will, I think, involve a little bit less typing and more like you can just kind of sit back and follow along. So let's come back in 15 minutes and continue with the second half of the lesson. Yes. All right, folks. Let's continue with our high intensity introduction to plotting with pandas and Matplotlib. Obviously, with a 7-week-long course, we kind of have to sometimes go a little bit quickly through things, and we'll see how we do with the second part of the lesson here. I'd like to leave Volko a couple minutes to introduce the exercise for this week to you. But we'll more or less continue along the same lines of what we started doing in the first part of the lesson with plotting our data using pandas and Matplotlib. But now we'll go into some slightly more advanced topics. Most notably, the biggest thing we'll introduce here are the use of subplots. So you can see a nice figure here at the top showing temperature data that's divided now by season. And you can see then variations in temperature during the winter, spring, summer, and autumn. And what we'll do by the end of this piece of the lesson is produce a plot like this ourselves with these different seasonal temperature values. And this is sort of also going to be related to what you'll be doing for the exercise for this week. So hopefully this proves useful for you. If you've not already figured it out, we're in the advanced plotting notebook, so you can open that up and we're going to get started here. If I remember correctly, there's a bit less typing in this lesson, so hopefully it's a little bit easier for you to just kind of run some of the cells and listen to what's different and just follow along. As we are in a new notebook, we need to start off here at the top by importing pandas and the Matplotlib pyplot libraries. So same as we did before, we're going to import those two. We won't be using the bokeh, pandas bokeh extension and the plotting backend here in this lesson, although we certainly could. We did not modify the lesson to do that for this time around. There are some nice things you could do with pandas and bokeh here. We're also going to load the data basically in the same way that we did previously. So this is exactly the same data set that we were using in the previous part of the lesson, and this is the same format for loading the data file, so you just need to press Shift Enter. Again, we're going to have our data indexed by the date column. And well, let's take a look. We never really checked out our data in too much detail last time, so we're going to take a bit more time to clean up our data in this case before we do our plotting. But we can do something like if we want to say, see how many rows of data we have here, we could print out the number of rows. Kind of going back to our old days of lots of print statements. And then we could print out len of data to show us the number of rows of data that we have here. If you run this cell, you'll see we have a pretty good sized data set. So 931,000 rows of data. This obviously would be something that things like Excel would have a bit more difficulty dealing with, but with pandas it's actually not too difficult once you load the data file, and we'll easily kind of prune away the data we don't need and things like that with our approach. But yeah, nearly 1 million rows of data is pretty impressive amount of values to deal with. If we take a little bit closer look here at the things we have in our columns, we can see, for instance, if we run print data.head, just like we did before, we'll see that we have our data indexed by the date. It's a DateTime index here. And then we've got a temperature column and a maximum and a minimum temperature column, just like we had before. All the same stuff that we saw in the previous lesson. We can do one thing, and since we've already done this once before, we don't need to type it in. And that is we'll rename the temp column to be temp_F. We will convert the temperatures from Fahrenheit to Celsius in this this part of the lesson. So let's go ahead and rename that temperature column from temp to be temp_F using a dictionary here called new names, and then the data.rename method to rename that one column. So I'm just going to run that cell so that we don't have any confusion between temp and some other temperature value later on that we might encounter. All right, so as I mentioned, we're going to do a little bit more cleaning of the data in this part of the lesson than we did previously. Last time we just jumped in right away to plotting. But there is a decent amount of missing data in our 931,000 rows of values. We can take a look at how much data is missing. We'll add some nice print statements here so we can have nicely formatted versions of this. But if we look at the number of missing data values per column, we can then print out the output from a pandas command here, data.isNA. So this will tell us any place where there is a not a number value, or that any location where there's a not a number value. And then if we do .sum on that, then for each column we should get a sum of the total number of missing data values for each one of the columns. So if you run this cell with the data.isNA, normally the output would just be true or false. For each location, each row would be a true or false of whether it's not a number or an actual value. But then when we do .sum on top of that, we just add up all the trues. And we see, for instance, here with tempf, that we've got about 3,500 or nearly 3,600 missing temperature values in our tempf column. There's a whole bunch more missing from max and min. We're not going to worry about getting rid of those, but it would be good to drop out the missing temperature values from our tempf column because there's no point in keeping them around. Of course, we can do this with the data.dropNA. I guess you guys saw a little bit about dropNA last week and in the exercise. In this case, we'll subset it because we don't want to drop everything that has an NaN value. But we'll say we have a subset that's equal to temp underscore f. So that means we'll only drop rows of from our data frame where temp f is not a number value. And we'll also do this with the in place equals true parameter. So we could do the same thing and just say data equals data.dropNA, or we can use the in place equals true, which will modify the data frame itself. So if you run that, we should drop out these 3,500 missing values for tempf. And now if we print out our number of rows after dropping NaN values, we can see that len data will be smaller than it was before. We expect about 3,500 fewer values than we had previously. And if we run this, we now see that there's 928,000 rows. We had about 31,000 and something before, so that's about 3,000 lower than it was before. Looks like it worked. If you didn't do this in place equals true part, you would see the length of the data would not have changed because you would have dropped the NA values but not actually modified the data frame. I guess we've seen some of this stuff last week, so is this part fairly clear? Okay with the data cleaning steps so far? Pretty standard procedure that we read in the data file, take a quick look at what we're dealing with, and then try to get rid of stuff we don't want, like NaN values, and that's exactly what we're doing here. The next step is also something that should be familiar, and that is converting our temperatures from Fahrenheit to Celsius. So we'll do this, you saw with the lesson and the part of the materials that Volkel presented last week, several different ways we could do this. We could define a function and apply it. We'll just keep it simple and make a new column in our data frame called temp underscore C. If we have temp F, temp C is a pretty good way to identify our temperature values in Celsius. And we'll say our temp C is equal to data temp underscore F minus 32 degrees. And we'll go ahead and put this in parentheses. And then we can divide that by 1.8 or by 9/5, which will then convert our temperature values from Fahrenheit to temperatures in Celsius. So that's our familiar equation. I think we've probably seen this in nearly every lesson of the course because it's pretty standard operating procedure to convert temperatures from Fahrenheit to Celsius when you have these NOAA data sets. So now if we take a look at our data.head, we expect to see a new column called temp C, and we expect to see that the values in temp C are temperatures in Celsius. And at first glance, this looks to be okay. 36 degrees is a little bit above freezing, and so is 2.2 Celsius. So at least without going through and checking things in exhaustive detail, this looks okay. We could also do head.tail, or sorry, not head, data.tail, and take a look at the temperatures in some other temperature range and see if it looks okay, or data.head with a larger number of values, whatever you want. See if we could find something where we've got 32 degrees to show us clearly that our temperature conversion works, but this looks okay to me. Okay, so we've cleaned our data. We've converted our temperatures from Fahrenheit to Celsius, and now we're ready to get to work with our subplots. There will be a series of these things in which there is an example of how to do some part of the command that's already filled in for you, but that the first one we'll type in together. This is a good thing just to make sure that you're following along and typing as we go. What we're going to do with our subplots is we're going to make a series of 4 different plots for each season of 1 year of data. So we're going to start in December of 2012 and go through to November of 2013. The reason we're starting in December is because we're going to define winter to be from December 1st until the end of February. This is kind of one way in which you can define the season without worrying about like when the solstice and equinox and things like that are. So we'll say December to February is winter, March to May is spring, June to August is summer, and September to November is fall or autumn. And so what our first step is going to be is we're going to make a series of different data frames, and our data frames will contain only our temperature values for a given season. So if we start here, for instance, with winter, we could say that winter is equal to our data.loc. So we'll get the locations or the values of our data, where our data.index is greater than or equal to the first day of the time range we're interested in. So this is going to be now in the format of a character string, so 2012, and then the month of December, first day of December, and then 0000 for the hour and minute. You don't necessarily need to include those, but since we've been putting in the hour and minute earlier, let's just do it that way. So that should give us all dates that are within the index range of after the first day of December in 2012. Now, as you can see here, I've put things in parentheses, which means that we're going to be using 2 conditions. The other condition, of course, is that our data.index is less than 2013. We don't want to include March, so let's say it has to be less than March 1st of 2013 at midnight. So that should give us to the very end of February as our temperature range that we're selecting, or our date range rather that we're selecting, in a data frame called winter. So that'll take a slice out of the data frame and store it in a new one called winter that has only these values from December 2012 to February of 2013. If we want to then create a nice data series, winter temps. We can pull out just from the winter data frame the values of temperature for those stored in Celsius. So we can say winter temps equals winter of here then just temp C. So we'll just take this single column temp C out of the winter data frame, which means we'll have a data series called winter temps. If you look below, you'll see the same thing happening for spring, summer, and autumn. Lucky for you, you don't have to type that in because it's a bit cumbersome and just, well, it's not bad experience necessarily, but it's just tedious. So if we run this, should have no problems. We'll now have generated 4 data series. And now we can take a look at plotting some of the data. So for instance, for the winter, we'll create an axis object or a set of plot axes that are generated when we run winter dot, I guess we could do winter temps dot plot, even though that's not what's shown here in the example. We could do winter temps dot plot. That should basically do the same thing as if we said winter temp C dot plot. I don't know if I just typed that in incorrectly, but let's go ahead and just alter these other ones so that they say whatever underscore temps. Since we made these data series, we might as well use them. But yeah, AX1 equals winter temps dot plot, nothing else given to it. If you run this cell, of course we don't have axis labels that make any sense, but we can see here temperatures, and they look, at least at first blush, to be reasonable temperatures for the winter in the sort of vicinity of the Vantaa airport. So we've got a couple cold days here. I think I moved to Helsinki on the 2nd of January in 2013, and I do remember it being fairly cold not long after I arrived. It was a reasonably cold winter that year, and I'm not scared of minus 28, but minus 28 is cold. So I remember this particular year pretty well. If you run these other cells, then you'll see the same thing for the spring. Notably, we didn't get above freezing until around middle of April. I also remember that because there was snow on the ground for quite a while. But then we had, I think, summer temps, a reasonably nice, not super warm summer, but pleasant. And then I don't actually remember what happened in the fall. I think I spent a lot of time indoors here in this building or one of the neighboring buildings in the fall, so I don't exactly remember what was going on. But yeah, we can see what look like reasonable trends here. It's warming up in the spring, summers, temperatures are comfortable, and then cooling down in the fall. Everything looks okay so far. But what we have right now is 4 separate plots. And what we would like to have is 4 plots together on a single figure. These are one plot on one figure as things are set right now. The other thing we want to deal with, though, is if we want to put these 4 plots together, it is nice if you're comparing between seasons that the range of temperatures between, like on each one of the plots on the y-axis is consistent. So that like when you look quickly, you can see that, you know, things that are plotting up toward the top of the plot are warmer than things that are plotting down toward the bottom by setting the range of temperatures to be constant on each one of the plots. So we have to figure out what those data bounds are. What is the minimum temperature value that will contain our data? What's the maximum temperature value that would contain our data? And then we'll add a few degrees to give some padding on the top and bottom of the plot. So this is something that when you make the plot by itself, automatically pandas will figure out what the reasonable values are for the limits of the x and y axis to contain your data so that things aren't like popping off the edge of the plots. But here, because we're going to have one, for instance, winter temps data series that's plotted, and then also we'll be plotting summer temps, they don't necessarily know when you plot them on separate sets of axes what the range of values are for the temperatures on the other subplots. So we have to figure that out ourselves. And this is one way in which you can do it. There are several different approaches, but we'll do it this way. That we could define a variable called min_temp. And this follows kind of my approach to how I would do this. Vocal might have a different idea for how to do the same thing, and I think if you found any other Python user, they would probably also have different ideas about how to do it. But for me, I like to use the min function, and then find for each one of the seasons what is the minimum temperature. And then once I have the minimum temperature for each season, if I use the min function to find what the smallest number is out of those 4 seasons, then I get from that the minimum temperature for that year. So for instance, if I say min of winter temps, I don't again understand why I typed this in this more clumsy way earlier, but if I take min of winter temps dot min, so winter temps dot min is going to give me a single number back. That is the minimum value of a temperature in the winter temps data series. I could then also take spring underscore temps dot min. That'll give me the minimum temperature during the spring data series. Summer temps dot min, which will give me the minimum summer temperature, and then autumn. I'm sort of being nasty by making you type autumn instead of fall. Dot min will give me the minimum temperature for the autumn. By wrapping this all inside the min function, then out of those 4 numbers, I will just get back the minimum value. Of course, we expect that to come from the winter, but this is a safe way to do it, that if we had some anomalous warm winter and super cold spring, that we don't just assume the winter is the coldest temperature, although it was in this particular year. Once we've gotten those 4 minimum values and found the minimum of them, what we can do then is say min underscore temp equals min temp. Oops, I guess I need my equal sign in there. Equals min temp minus 5. So this is going to add 5 degrees, or sort of 5 degrees of padding at the bottom of the plot, so that normally if we found the absolute minimum temperature in the winter, we don't want the plot to go down to the bottom and hit the axis of the bounds of the figure. We'll add a few degrees of padding so that there's 5 degrees of extra space below the minimum value when we define our plot axes. So this is done the same way below. It's basically doing the same thing. We could either do winter and then take the temp C column out of there, or winter underscore temps. This will give exactly the same results because winter temps is defined as the temp C column out of the winter data frame. I'm just going to convert these quickly, and I think I'll fix this on the lesson materials after we're done, because otherwise there's no point to have made these data series. And I think I'll also just put this onto one single line so you can see that. But when we deal with the maximum temperature here, all we do is we find what's the maximum temperature for each season and then take the maximum value out of those 4 seasons. Same idea, just using the max function now. And then similarly, once we find the maximum temperature value for the given set of seasons, we then add 5 degrees so that when we go to plot things, we've got some padding on the top of the plot. If you run this cell, you'll find that in beautiful symmetry, the minimum temperature was minus 35 and the maximum temperature is plus 35. That's 5 degrees above and below the actual maximum and minimum temperatures. So our actual minimum temperature in the winter was about minus 30. Actual maximum temperature in the summer was about plus 30, but we've added 5 degrees so that we'll have some extra padding, and you'll see what that looks like when we get to the plot. All right, so let's make some subplots, and we can do that now by taking a little bit different format than what we did before. So now we're going to have fig comma axes equals plt.subplots. This is coming straight out of Matplotlib. So this is why things look a little bit different than like before. We had ax equals some DataFrame.plot or whatever. Now, the subplots command is what allows us to put more than one plot onto a figure in Matplotlib. And when you use this command, it returns not only the axes for the plot, but also a figure object so that you can refer to things that are on the figure as a whole or to individual plots, which are the different axes that are used to display the information on the plot. So plt.subplots will say that n rows equals 2. N calls equals 2. So we're going to have 2 rows and 2 columns of plots. That'll give us 4 in total. You could arrange this differently if you wanted 4 of them in one column, 4 rows. You can do it that way too, but this is how we'll do it here. And we can also specify, because we're doing things this way, fig size. So this is nice because we can tell, what do we want the size of the figure to be. Let's say 12 inches wide by 8 inches tall. That will make a nice big figure for our example here. And then if we look at our axes here at the end, we're just going to print out what is in the variable called axes. Just so you can see that this axes is actually an array. It's a NumPy array. We haven't dealt much with NumPy, so you don't necessarily need to worry about that. This should look somewhat familiar. Back when we had a single pandas plot and we checked the type of AX, it was the same matplot axes, subplots, axes, subplot. This is just one plot axis, one set of axes for a given plot. In this case, it's the top left one. And you can see here that this is a list of 2 values here. These are the top 2 in the first row. And then there's 2 more values that are listed here that would refer to the axes in the bottom row. So there's those 2 there. By assigning this plt.subplot to the variable called axes, that means that we can then talk to the plot and say we want to put certain things on certain axes. We want to maybe have well, a common example would be if we have a plot in a layout like this, that maybe we want to label only the y-axis on the left side of the 2 plots on the left and not have the y-axis labels over here if it's plotting the same data. Same thing goes that maybe we want to put the x-axis labels only on the bottom 2 plots, not on the top ones, just because it's sort of redundant. But we can also do this, that we can rename these things in a little bit more intuitive way so that we can refer to individual plots. Like here, we have column number 1 on row 1, so columns 1 and 2. So the first plot, top left, is AX11, and then AX12. This is just a shortcut way to be able to refer to the individual plots that we have here. So this would be the top row, then on the left side and on the right side, and then those starting with 2 would be the second row, and then 2-1 is the first plot, 2-2 is the second plot, the one on the right in row 2. So if you just run that cell, nothing gets output. It's just renaming the variables so that we can refer to individual plots a little bit more easily. Now we're ready to do our thing and get our data plotted. So first off, in the plot, we're specifying the line width of 1.5. We haven't seen this before, but I'll show you how that works in just a second. It allows us to change the thickness of the line. So you can make them thinner or thicker depending on what you're plotting, how big the plot is. But what we'll do is we'll do winter temps dot plot. So this part should look familiar. The thing that's new here is we're not doing AX equals winter temps dot plot because we've already created our plot axes. When we did the subplot thing, we made space where all of this information can be plotted. So now what we need to do is tell pandas where to put our plot. So if we say winter temps dot plot AX equals AX11, it will say put that data for the winter on the top left panel. We can then also specify some things we haven't specified previously, like color. So the shorthand notation in the pandas plotting for color is just to say C equals, and then you give some string like this, like C equals blue. That'll give us a blue colored line for the top left plot. We can also say that the LW, or line width, equals line underscore width. Since we've defined the variable here already, we can just specify the line width that way. And the other thing we need to add in here that we have not seen, or that we haven't included at this stage, is the y limit. Remember, we want to have the range of temperatures be the same on all of our plots. The time is going to be different, so we'll let the pandas sort out, what time range goes for each one. But for the y limit, we want to have that go from our min temp to max temp, because we defined those things a couple cells ago up here. We had min temp and max temp as our minimum and maximum temperature values for the whole year of data. Again, I apologize for having done this with the data frames in this way. I'll just convert this quickly, although it will make no detectable difference in the plots themselves. But I'll just put all this stuff onto a single line since we can. So just do that summer temps dot plot, autumn temps dot plot, and our y limit in this case for all of the plots is the same, which means that our temperature range on the y-axis should be the same for all the plots. In the end here, we also do have to add this fig command to get the figure to be displayed, because by default it would not be displayed otherwise. But if you run this cell, ooh, look at what we did. We now have our winter, spring, summer, and autumn temperatures plotted on 4 different panels of a single figure. So this is our subplot example. It's looking a lot like what we were supposed to do at the very top, where the kind of motivation for this part of the lesson was shown with that nice 4-panel plot. There's a couple deficiencies you can see here. We don't have axis labels. That would be good to include, right? So as good little plotters, we should have our axes labeled. You can also see some issues with overlapping plot boxes and the locations of the tick labels along the x-axis. So we can make some small changes to improve things with that, as well as maybe adding some labels in here to show which season we're looking at, because right now you have to kind of know what season the temperature data is coming from in order to be able to see what season we are dealing with. So we can fix a few things here. First, we can just run this cell that's underneath our plot. By running that, we're just going to make a new set of axes that are ready for data to be plotted on them. So here we just have a set of blank axes. And down here at the very bottom, we now have our final plot that we have produced. Things basically look the same as what we had before, with a couple small differences that I'll just highlight here quickly. One is that now we're including this grid equals true parameter. That will add a grid behind the plot, which sometimes can make it nice to see the horizontal lines going across for a constant temperature as a nice reference point, for example. So we now have grid equals true for all of the plots. We've also added this fig.sup title. So this SUP, not SUB, but SUP title is like a title that's going to go across the top of the figure. So instead of being over one single plot, this goes above all 4 figures as a kind of figure title. So now we have 2013 or 2012, 2013 seasonal temperature observations at the Helsinki-Vantaa airport. And we've also tweaked the axis rotation by, the default I think is to have it rotated 30 degrees from horizontal when you have these DateTime labels. We've decreased that rotation to 20 degrees. That will rotate them just enough so the plots don't lay on top of the axis labels. This is something that if you're interested, you should probably go take a look at the Matplotlib documentation, because this is kind of digging in a bit more deeply. When you start rotating your tick labels and things like that, you're getting a bit deeper into the plot formatting. It's not just changing the line color. So the documentation for Matplotlib is abundant, which can be sort of intimidating sometimes because it can be hard to find things, but you should be able to find things. If you look for tick labels and rotation, you would find documentation about how to alter this if you should want to do that. And then finally, as I mentioned before, because we have these different axes identified, like AX21, AX22, AX11, etc., that means we can add X labels and Y labels to specific axes to have our plot look nice and have labels on only the axes where we want them. So we add date to the two axes on the bottom, where on the x-axis on the two plots on the bottom we'll now have date, and then on the y-axis of the two plots on the left side we'll have temperature. And then finally here we can add some text labels to show which season it is by converting our date time to some time that's within the range of that season, and then putting the temperature down at minus 25 degrees, just because that'll put it down in kind of bottom right corner of the plot. If you run this cell, probably many of you have already done it, you'll see that we indeed produced the plot that we started with at the top. And although it's perhaps been kind of quick to get there, you can see that the steps we're taking along here aren't necessarily giant leaps. I mean, it's basically just sort of building up from what we started with, data.plot. But now we add this subplots thing in there, so we can say, well, we can put the plots onto different different axes. You know, as I mentioned before, if we wanted to change the orientation of the plots, we could do that. Thinking about it right now, it's probably not the best thing to do, because if we make the number of rows, for instance, 4, and the number of columns 1, then I think I have to then change this also and make all of these 0. I don't even know if it will make this. No, it's not subscriptable because it doesn't have a second. There's only one column that doesn't have a second axis there. But for instance, we could do that just by changing one thing with the subplots to now have 4 rows, 1 column. And once we've done that, if we go back and run our plot again, you could say, hey, maybe this looks better if we plot our data this way. Now, of course, our tick labels are being covered up by the plots even worse than they were before. So this doesn't resolve all of the issues. There are some ways to improve things, but just as an example to show that, you know, once you've got a working plot, you can start tinkering with things, and it's not, I mean, in the end, when you look at this, it looks pretty heavy, but each little piece in there and each step that we've kind of gone through are relatively small things that in the end add up to be a pretty fancy looking plot. Of course, I've ruined it here, but you can scroll back up to the top of the lesson to see the nice looking version. I think I've succeeded in leaving a few minutes for Vuoko, but are there any questions about the pandas plotting stuff at this stage? Maybe just a quick informal survey. How many of you feel like this is not that complicated? Okay, that's good. If we ask the same survey after the exercise this week, I don't know that we'll get the same responses. But I'm glad that you don't think it's too bad at this point. That's encouraging. So, yeah, why don't we take a look at the exercise
yeah.
then?
Yeah, so I'll take 5 minutes or so extra, so if you need to leave, I don't mind, but let's check what is the exercise about this week. Where do I have the lesson page? Okay, so exercise 7, you can clone the GitHub Classroom. It wasn't working at some point, but now it should work. Let us know if there's any problems with that. So you can open it. Let's see if this renders the pages, but just to look at the README file, maybe I'll refresh this once. Okay, so we have a bit more problems for you for the final week. So this exercise is worth 30 points in total. So a bit more than the previous ones, and basically problems 1 through 3 at least cover the things Dave just walked you through in the lesson. So we'll be plotting a scatter plot
a line plot, and then kind of similar 4-panel subplot. And then we have some optional exercises. So there's a little task for creating a GIF animation. I'll show an example soon. And then we have a final extra task that is worth 10 points. So you don't need to do it, but for example, if you feel overwhelmed by some of the stuff in problems 3 to 5, you could even do so that you skip some of them and do the final exercise however you wish, but the kind of total course points are the 20 points per each weekly exercise up until now, plus then 30 points from this final exercise 7. Let's see if GitHub collaborates and renders these, otherwise I'll just show these in the CSC notebooks because there are some nice example maps. Probably not, so I'll just do this. Let's see. So as usual, you can start working with the exercises by cloning your personal exercise 7 repository. There we go. Dave has no exercises. Git clone command V. Okay, so I can show some of the stuff from here. Yes. Okay, so in problem number 1, oops, sorry. Today I did not put the external mouse, and that's why, this is why I usually have it. Okay, so we'll create a scatter plot of random candy points, let's say. So often when developing code or doing stuff, you just generate some random numbers and then work with those. So there are a few pieces of code ready for you where we use NumPy to generate random numbers. So this plot basically has 1,000 random x values, 1,000 random y values, and then 1,000 random color values. And then we plot those and adjust a bit the colors and the properties. Yeah, so basically generate random numbers, plot a scatter plot, add axis labels, title, and then save the plot onto disk. So there's some lines of code we have given readily for you, and then the rest you should be able to do with the help of hints. There's some additional hints here, and then the lesson materials. So that's quite a fun and short task. Then line graphs. So there is a, well, I don't know, not so beautiful, but anyway, a line graph of temperatures from a 30-year period. So basically here we instruct you to plot data from 1988 until 1980. So basically, I guess the average age in this group would be something around 20 to 30 probably. So the temperatures during our lifetimes, let's say so. So let's plot a line graph out of those kind of simple tasks. So here we have an input data file, Helsinki-Vantaa CSV, which has this information that you were producing, kind of similar information you produced in exercise 6. So there are monthly average temperatures in Celsius, and then there's a reference temperature for the 30-year period, and then there's a difference between the monthly means and then the reference. So monthly temperature anomalies are there as well, and those we'll use then in the following problem. In this problem, we'll be just using this temp-C column. Okay, and then there's again some additional hints. Basically, you read in the data, you plot XY plot and adjust some of the plot properties, line style, line color, markers, XY labels, title, and then finally save the figure. Okay, then still kind of the biggest or maybe the more demanding problem. So to repeat this 4-panel plotting that Dave just introduced, but now using the temperature anomalies data. So we provide the data ready for you for this exercise, and the goal would be to plot something like this. So one subplot for each season, and then you can see temperature ranges from -6 to +6, and then you can see the temperature anomalies across the 30-year observation period based on this data. So that's the goal, and we have breaking this down to different steps you can follow. You'll have to then continuing the bar plots. So in problem 4, you'll create a bar plot for 1 year of the seasonal temperature anomalies. So in this example, we will first do a bar plot for year 2012, where kind of winter was kind of colder than the average, spring was a bit warmer, summer was a bit colder, and so on. To practice with one year of data, and then here you can see that we have colored the bar plots according to if that season was colder or warmer than the reference temperature. So if the difference was greater or below 0. And then basically in the following problem, so this is the final kind of compulsory problem, you would repeat the process for each year. So here we have already put it into an animation, but basically what is behind this is that you, for each year in the time series, you plot the bar graph. So that's done in here, so you can reuse the code from problem 4, put it into a for loop, and change a few things to produce then, well, yeah, 30 PNG files. And then the actual GIF animation, you don't have to do it if you don't want to, but basically there's a script for doing that. All you need to do is to change the file paths and run the code to then put these PNG files into one .gif animation file. So those are those. Then in addition, we were developing this kind of final task for you where there's minimum instructions, but the goal would be to look at this 30-year period of time, and for each month find out the maximum and minimum value during the observation period, and then plot those. So in a way it's, well, kind of simple workflow, but you need to think about data groupings and selections and such. So you would read in the data. Here the starting point would be to download the data from lesson 6. So start from the raw data, read in the data, convert Fahrenheit to Celsius, calculate monthly means, and then based on the monthly means find out the all-time maximum and minimum values, and then finally plot them. So this is maybe not as cool as I thought, but then you can of course the idea would be to make an interactive bokeh plot that you could hover over, for example here, and see which year did this maximum January temperature occur. Yeah, so this is totally optional, but if you do this you can compensate some minus points from other tasks. Yeah. Any questions about the exercise? Deadline, of course, we now set it to Monday 28th of October by 4 p.m. So you would have almost 2 weeks time. If there's like a public uproar that you really need more time, we can then discuss that closer. But then in order to give you also the feedback and the grading, I think that should be enough time for this final exercise.
Yeah, I would say one other thing about the final problem is that we talked about it a little bit yesterday, that you could also deviate a bit from this kind of plot. If you've got some other idea of how you would like to display the data, there's lots of different ways in which you can show things, like these temperature data. So if you think, for instance, you want to show how the data cluster, that there's more warmest months on record, more recent history, then you could try and see if that kind of plotting with temperature on the vertical axis and time on the horizontal axis is in terms of years rather than months. interesting way to look at the data. This is a bit more, open-ended in the sense that we want you to kind of explore and do things on your own. And
and if you come up with another idea, make some other kind of cool animation using the skills you have, feel free. And also in all these exercise 7 problems, we have produced the kind of model solution, but if you get creative, you can of course experiment. It doesn't have to be super exactly identical to the plot, the example plot. So
I think the only thing is that if there's something that's requested, like access labels, those kind of things should be there. But if you then choose to use slightly different colors or whatever, of course there is a certain artistic element to making the plot as well.
Okay, but that's it for this week, and I guess for the Geo-Python part of the course. So now there's one gap week, no teaching. Do go to the practical sessions on Thursday and Friday to get help with these exercises, and let's chat on Slack and then continue. So we'll be using the same Slack environment also in period 2, so don't exit there. But thanks.